Good morning, children. So today, exercise 8.2, question number 5. So it is given that ABCD is a parallelogram in which E and F are the midpoints of the sides AB and CD respectively. So the given figure is a parallelogram ABCD, and then the points E and F. So E and F, they are the midpoints of the sides AB and CD. So E is the midpoint of AB, and then F is the midpoint of CD. You are to prove that the line segments AF and EC trisect diagonal BD. So you are to prove that the segments AF and then EC trisect diagonal BD, which means you are to prove that this diagonal BD should be divided into three equal parts. That is, DP equals to PQ equals to BQ. That is called trisect. So now, as you have learned one of the theorem that supposing this is a triangle, you have learned the converse of midpoint theorem. So say this is a triangle ABC, and here a line is drawn. Say this is point D and this is point E. Now here let us assume that D is the midpoint of the side AB. That means AB equals to DB. Now through the converse of midpoint theorem, you have learned that line drawn through the midpoint of one side of a triangle. So the triangle is ABC, one side that is AB. Through this midpoint D, the line is drawn parallel to another side, that is the side BC. Then the line will bisect the third side. The third side is AC. That means E will be the midpoint of the side AC. So in this case, as you are to prove PQ equals to QB equals to DP. So here they have given that these are the two midpoints of the sides AB and DC. Now to make these two lines parallel, they have not given that these two lines, that is AF and CE, are parallel. So they have not given, as like this, here DE is drawn parallel to the side BC. Then this line will bisect the third side. So in this case, they have not given that these two line segments, that is AF is parallel to CE. So you will make at first, number one, you will make quadrilateral AECF. So AECF is a parallelogram. So you will make this figure parallelogram. In that case, you will get both the pairs of opposite sides are parallel and equal. So in that case, you will get AF is parallel to CE. So AF parallel to CE. So now, if supposing, so now how to make AECF parallelogram? So let us take in this way that DC equals to AB. So DC equals to AB. This is due to opposite sides of a parallelogram are equal. So now as F and E, these are the two midpoints of the sides AB and DC. So you can take half. So half of DC is equal to half of AB. So now here AE, BE, half of AB, because E is the midpoint of AB. CF equals to DF, half of DC, because here F is the midpoint of DC. So now half of DC, you will take CF. So here CF equals to half of AB. So half of this AB, you can take AE, because E and F, they are the midpoints of the sides AB and DC. Again you see here, you can take that CF is parallel to AE, because the figure is parallelogram. ABCD is a parallelogram. So that is why the opposite sides are also parallel. So AB is parallel to DC. Since AB is parallel to DC, that is why CF is parallel to AE. Now you compare these two. So So you have got one pair of opposite sides equal as well as parallel, because here CF AE CF AE. Once it is equal, second time it is parallel. So the same pair of opposite sides equal as well as parallel. Therefore, AECF is a parallelogram, which means AF is parallel to CE. So you have made these two lines parallel by making the figure AECF parallelogram. Now you take the triangle. Say you take the triangle, say APB. Say in triangle APB. So in this triangle APB, you have got that E is the midpoint of the side AB, because they have given E and F are the midpoints. So here E is the midpoint of the side AB. So in this triangle APB, E is the midpoint. So E is midpoint of AB, and so the line segment, that is the line drawn through the midpoint of one side of a triangle. So the one side is AB, so the triangle is APB. So this is the triangle, so this is the first side where E is the midpoint, and through this midpoint the line is drawn parallel to another side, that is the side AB. That means EC is parallel to means FA. In that case you have got EQ is parallel to AB. So this is the first side, this is the second side. So this line that is drawn through the midpoint will bisect the third side. So the third side is PB. So here Q has become the midpoint of PB. In that case PQ equals to QB. So you have used the converse of the midpoint theorem. So now that is why you have made this figure AECF parallelogram. From there you got AF is parallel to CE, and then you will take the triangle APB once, and then you will take the triangle CQD. So you will make first PQ equals to QB using the converse of midpoint theorem. Then from the triangle DQC you will get DP equals to PQ. So by equating the two equations, you will get these three segments will be means equal. In that case, the two line segments AF and then CE will trisect. That means dividing the diagonal BD into three equal segments. So now let us take the proof. So the first condition, you will make AECF parallelogram, whereby you will get AF is parallel to CE. So now first here, so AB equals to DC. So AB equals to DC. Why? Because here ABCD is a parallelogram, since opposite sides of parallelogram are equal. Now it is given E and F midpoints of AB and DC. So that is why AE, DE half of AB, then CF equals to DF half of CD, because E is the midpoint of AB and here F is the midpoint of DC. So now you will be dividing by 2. So half of AB equals to half of DC. That means dividing by both sides by 2. So now half of AB. So these two segments are half of the whole length AB. So that is why half of AB you will write AE. So it will be AE equals to, so half of CD. So each of the segments CF, DF, they are the half of CD. So you will write CF. So it is CF. Why? Because here E and F. So E and F. So E and F are midpoints of AB and CD. AB and CD. So you have got this. Next, you can say that AE parallel to CF. So AE parallel to CF. Why? Because the figure is parallelogram, and in a parallelogram opposite sides are also parallel and equal. That is why AB is parallel to DC, whereby you got AE parallel to CF. So AE is parallel to CF since AB is parallel to CD. Now from these two equations, the same pair of opposite sides AECF, once it is equal, next it is parallel. So the same pair of opposite sides equal as well as parallel. Therefore from these two equations, therefore quadrilateral AECF. So AECF is a parallelogram. So therefore you have got both the pair of opposite sides are parallel. In this case AF is parallel to CE. Therefore AF parallel to CE. So now you will take the triangle ABB. So in that case you will get that Q is the midpoint of PB, where BQ equals to PQ. You will be using the converse of midpoint theorem. Then the next you will take the triangle CQD, where you will get PQ equals to DP. In that case, by just equating the two equations, you will get these three segments will be equal. So in triangle ABB, so now is the midpoint of the side AB. This is the first side. The line drawn through the midpoint of one side of a triangle. So the triangle is AEB. So this is the first side where is the midpoint, and through this midpoint the line is drawn parallel to the other side. So the other side is AB, which is the second side. So this PB becomes the third side. In that case, the line drawn through the midpoint parallel to the other side will bisect the third side. That means Q is the midpoint of PB. In that case, PQ equals to QB. So now in the triangle APB, E is midpoint of the side AB. So this is the first side. Through this midpoint, the line is drawn parallel to the other side. So the side is AB. This is the second side, and this PB becomes the third side. So N EQ parallel to AB, because you have proved that AF is parallel to CE. So AF is parallel to CE. That is why EQ is parallel to AB. Since AF is parallel to CE, now this is the first side where E is the midpoint of the triangle APB, and through this midpoint E, the line is drawn parallel to the other side, that is AP. EQ is parallel to AP. Then this line drawn through the midpoint will bisect the third side. So here PB becomes the third side. Therefore, Q is midpoint of PB. This one you have got it by the converse of midpoint theorem. Converse of midpoint theorem. So since Q is the midpoint of PB, in the triangle APB, therefore PQ equals to BQ. Therefore PQ equals to QB. This is equation 1. So you took this triangle. Now you will take the triangle DQC. So in triangle, so DQC, so DQC, where you got F is the midpoint, F is the midpoint of DC, and through this midpoint the line is drawn parallel to the other side. So the other side is CQ. So this is the first side where F is the midpoint, and through this midpoint F the line is drawn parallel to the other side, that is CQ. CQ becomes the second side, and this DQ will become the third side. Hence the line drawn through the midpoint will bisect the third side. That means P becomes the midpoint of DQ. So in that case DP equals to PQ. So these two segments will be equal. So now F is the midpoint of DC, and then FP parallel to CQ, and FP parallel to CQ, since here, so it is given that AF is parallel to CE. So this is the first side DC, where this F is the midpoint, and through this midpoint the line is drawn parallel to the other side. This is the second side, CQ. This is the second side, and this DQ becomes the third side. So the line will bisect, that is the line drawn through the midpoint F will bisect the third side. So therefore P is midpoint of, so DQ. So DQ. So this is also my converse of midpoint theorem. So therefore, since P is the midpoint of DQ, so that is why DP equals to PQ. So DP equals to PQ. This one is equation number 2. Now you compare 1 and 2. So DP equals to PQ, PQ equals to AB. That means DP equals to PQ equals to AB. So from 1 and 2, from equation 1 and equation number 2, so we get, so by comparing these two, so DP equals to PQ, PQ equals to QB. So DP equals to PQ equals to QB. So that means the line segments AF and then CE trisect, dividing the diagonal BD into 3 equal parts. So since these 3 segments are equal, so each of the segments of the diagonal BD has been divided into 3 equal parts, that is DP equals to PQ equals to QB. Hence the segments AF and then CE trisect the diagonal BD. Therefore the line segments, so AF and CE trisect the diagonal BD. So it is proved. So here the most important point you will get at first, you will make the quadrilateral AECF parallelogram, whereby you will get AF parallel to EC. So you will get these two lines parallel. Then by taking the triangle APB using the converse of midpoint theorem, you will get that Q is the midpoint of PB, where PQ equals to QB. You will get first equation. Then you take the next triangle DQC, where you will get that DP equals to PQ using the converse of midpoint theorem. So by comparing the two equations, you will get these 3 segments will be equal, which means the line segment AF and then CE trisect, that means dividing into 3 equal parts, trisect. the diagonal BD. So hence proved. We'll take the next question. So that the line segments joining the midpoints of the opposite sides of a quadrilateral bisect each other. So bisect each other. So here, so it's clearly given that so that the line segments joining the midpoints of the opposite sides of a quadrilateral should bisect each other. Now, so here they have said joining the midpoints of the opposite sides of a quadrilateral. So you will draw a quadrilateral. So it is a quadrilateral. Say this A, B, C, D. Now, here they have given this so that the line segments joining the midpoints of the opposite sides of the quadrilateral. So say the quadrilateral is A, B, C, D. So you will be joining the line segments. How? By joining the midpoints of the opposite sides of this quadrilateral. So they are the opposite sides. So you take the midpoints. By joining the midpoints of the opposite sides of the quadrilateral. So these are the two opposite sides and this is the next pair of opposite sides. So say here you join these segments. So here let us take P, Q, R, S. Now these are the two line segments. So PR, so these are the 2 points on the opposite sides of the quadrilateral AB and DC. So they are the opposite sides where we have joined the midpoints. By joining the midpoints of the opposite sides. So these are the opposite sides where you got P and R, midpoints of AB and DC. Secondly, you got the line segment SQ by joining the midpoints on the opposite sides AB and DC, where you got S is the midpoint of DA, Q is the midpoint of BC. Now they have said that the line segments, that is RP and SQ, you have joined it by joining the midpoints of their opposite sides should bisect each other. That means these two segments must be equal. Say this is given as O. Now we will join these points. So you have joined it. Now in this quadrilateral, so P, Q, R, S, you have seen that these two line segments, that is RQ and then SQ, these two has become the diagonals of this quadrilateral P, Q, R, S. So you are to prove that these two diagonals, that is RP and then SQ, should bisect at O. That means O must be the midpoint of SQ and then RP. So now, what we will do is, we will join one of the diagonals. You can join either BD or say AC. Let us join AC. Now, here, you have got the triangle ABC. In the triangle ABC, you have got the two midpoints, that is P is the midpoint of the side AB and then Q is the midpoint of the side BC. And from the theorem statement, that is the midpoint theorem, line segment joining the midpoint. So this is the line segment that is PQ joining the midpoints of two sides. So these are the two midpoints on the two sides, that is BC and then AB. So the line segment joining the midpoints of two sides of a triangle is parallel to the third side and is half of it. Which is the third side? So in the triangle ABC, so these are the two sides where you got the midpoints, and this AC becomes the third side. So in that case, the line segment that is PQ that joins the midpoints of two sides AB and BC will be parallel to the third side. So that means PQ is parallel to AC, PQ is half of AC. That is through the midpoint theorem. Then similarly in the triangle ADC, here you got the point S is the midpoint of the side AB, R is the midpoint of the side DC. So these are the two sides, and this side AC will be the third side. So the line segment SR joining the midpoints of the two sides. So these are the two midpoints. So will be parallel to the third side. So the line segment that is obtained by joining these midpoints will be parallel to the third side and is half of it. That means SR is parallel to AC, SR is half of AC. So from these two equations that you have got, you will get PQ is parallel to SR and then PQ equals to SR. So you will get the one pair of opposite sides equal as well as parallel. So in that case, quadrilateral PQRS will be a parallelogram, because you know that if a pair of opposite sides equal as well as parallel, then the quadrilateral will be called a parallelogram. And we know that the diagonals of a parallelogram bisect each other. So in this quadrilateral PQRS, when this has become a parallelogram, how this figure has become a parallelogram? You have made one pair of opposite sides equal as well as parallel. That means PQ is parallel to SR, PQ equals to SR. So in this case, from this point, this has become a parallelogram. Then these two, that is RP and then SQ, these are the two diagonals, and these two diagonals meet at point O. And we know that from the property of the diagonals that the diagonals of a parallelogram bisect each other. Hence the two line segments, that is RP and then SQ, they bisect each other at O. So here they have told you that so that the line segment joining the midpoints of the opposite sides of a quadrilateral bisect each other. So these two line segments, they are joined by joining their midpoints from the opposite sides. So these are the two opposite sides where you got R and P midpoints. So you have joined it, you got the segment PR, and then by joining these two midpoints from their opposite sides, you got the segment SQ. So now they say that these two segments should bisect each other. That means O must be the midpoint of RP and then SQ. So the first condition is that you will make the quadrilateral PQRS parallelogram. How? By using the midpoint theorem, where it states that the line segment joining the midpoints of two sides of a triangle will be parallel to the third side and is half of it. That is why here PQ is parallel to AC, PQ is half of AC. Similarly, SR is parallel to AC, SR is half of AC. So by comparing these two, you have got that one pair of opposite sides equal and parallel. So the figure is a parallelogram. And we know that the diagonals of a parallelogram bisect each other. Hence the diagonals RP and then SQ bisect each other at point O. So it is. Now the solution. So let ABCD be a quadrilateral, in which P, Q, R and S P comma Q, R and S are the midpoints of the sides A, B, B, C, C, D and D, A. So A, B, B, C, C, D and D, A. So D, A respectively. Now to prove, you are to prove that the line segments joining the midpoints of the opposite sides. So these are the opposite sides, so these are the midpoints. So the line segments obtained by joining their midpoints of the opposite sides, that is RP and then SQ. So line segments RP and SQ bisect each other at O, at point O. So this is point O. Now here comes construction. So you have joined. So here PQ, QR, RS, SP and the diagonal AC. So PQ, QR, RS, SP and diagonal. So AC are joined. So now the first condition in the proof part, you will use the midpoint theorem, where the line that is obtained by joining the midpoints of the two sides. So one side, two side. So the line segment is PQ, because these are the two midpoints, will be parallel to the third side. So here in the triangle ABC, AC is the third side. So here PQ is parallel to AC and PQ is half of AC. So in triangle ABC, so in triangle ABC, P and Q, so P and Q are the midpoints of the sides, so AB and BC, so AB and BC respectively. So the line segment that is obtained by joining the midpoints of the two sides of a triangle will be parallel to the third side. So here AC is the third side. So here PQ parallel to AC and PQ is half of AC. So therefore PQ parallel to AC and then PQ equals to half of AC. So this one you have got it by the midpoint theorem. So this is by the midpoint theorem. This will be taken as 1. Similarly, in the triangle ABC, where you get S and R, midpoints of AD and DC. So similarly, so in the triangle ABC, where S is the midpoint of the side AD, R is the midpoint of the side DC. So by joining these two midpoints, you will get the line will be parallel to the third side. So here AC is the third side. So here SR is parallel to AC. SR equals to half of AC. So similarly, you will get SR parallel to AC, and then SR equals to half of AC. So this one you will get it by 2. So the same reason, that is by the midpoint theorem. Now, comparing these two equations, so from equation 1 and equation number 2, you have got So PQ is parallel to AC, AC is parallel to SR. So these two lines PQ and SR, both the lines are parallel to AC. In that case, SR is parallel to PQ. So SR is parallel to PQ. And so between these two equations, PQ equals to half of AC, SR is half of AC. So that means PQ equals to SR. So PQ equals to SR. Now you see the same pair of opposite side, PQ, SR, PQ, SR. Once it is equal, next it is parallel. That means the same pair of opposite sides equal as well as parallel. So therefore, quadrilateral PQRS is a parallelogram because the same pair of opposite sides equal as well as parallel. And we know that the diagonals of the parallelogram bisect each other. So these are the two diagonals. So PR and then SQ. So they will bisect at O. Why? Because the figure has become a parallelogram. So if the figure is a parallelogram, in that case the diagonals will always bisect. Hence the line segments obtained by joining the midpoints of the means opposite sides, that is RP and then SQ will bisect at O. Again we know that the diagonals of a parallelogram bisect each other. Therefore, the line segments. So PR and SQ. So PR and SQ bisect each other at O. Each other at point O. So it is proved. So it is very simple. So first, what you have done, you have used the converse, you have used the midpoint theorem. That is, you have taken the triangle ABC, where on the two sides you have got the midpoints P and Q. So by joining these midpoints, you got the line segment PQ. So that will be parallel to the third side and is half of it. So you have got the first one. Then from the triangle ABC, so here S and R, these are the two midpoints of the side AD and then DC. So you got that the line segment that is obtained by joining the midpoints, that is the line segment SR, will be parallel to the third side. So that means SR is parallel to AC, SR is half of AC. So by comparing these two equations, you have got that the same pair of opposite sides equal as well as parallel. That means PQ parallel to SR, and then you got PQ equals to SR. So the same pair of opposite sides equal and parallel. Therefore, the quadrilateral PQRS is a parallelogram. Again, we know that the diagonals of the parallelogram bisect each other. Since these are the two diagonals, so these two diagonals, they will bisect at point O. Hence the line segments joining the midpoints of their opposite sides will bisect at point O. Thus it is proved. So that's all for today. Thank you.